Okay, guys. So I finished the challenge. I wish I had done it on the record here, but I couldn't do it on the record on video because it was too dark and I didn't think that the video was gonna come out right. But I finished the code and now I'm just gonna give you an overview. All that hard work, all that planning, all those mistakes paid off using core Java only. So first, let's go to the challenge. The challenge was, let's take a look, to write a Java program to add two binary numbers. And this is the W3resource basic Java challenges. There are 150 of them. Let me uh, retell. Okay, here it is. Java basic programming exercises, practice, and solution. Now, I don't look at the solution because what's the point? So the point is to challenge myself to write Java solutions using Java core as much as possible. So I'm not going to see their solution because I don't care. Now I want to show you my solution. Okay. Now let us switch to and switch to here. All right. Now that we're here, we can see my results. There's a couple of flags you'll notice. Line 2, this is some cycle, this is a flag. This statement is another flag that I use. Cycle is another flag that I use to track what my code is doing. And as you'll notice, there are a lot of if statements nested, and there's an else if statement also nested. So condition 1 is it evaluated, condition 2 is it evaluated within the if statements, that is the nested if statements. Is condition 3 evaluated? Is condition 4 evaluated? Now, these conditions are going to be evaluated depending on, of course, the circumstances or the conditions, whether they're met or not. We have the binary number 1 and binary number 2 up here on lines 8 and 9. And as you can see, the cycle, which is a flag that I use to track where I am in doing the calculations, and some cycle, which is a flag that I use to track where I'm depositing the sum of the binaries. Okay. And first sum is 0 plus 1, 1 plus 0, then 1 plus 0, then 1 plus 0, and then on the fifth cycle, 1 plus 1, and then 1 plus 0, and then 1.0. So, you know, if it's 1.0, you just, the sum is equal to 1. If it's 0 plus 0, the sum is equal to 0. But if it's 1 plus 1 in adding binary numbers, then sum is equal to 0, and you carry 1 over. So this is why I have this carryover array with only one index. So size 1 of size 1, right? And then I have the static I, which was supposed to be used, but I'm actually not. Let's take a look. Actually, I'm carrying it. I'm using it to mark the index of carryover because there's only one, right? This is going to be equal to 1 or 0 over here. And this will always indicate index 0 because carryover being length 1 only has index 0. As you know, arrays start at index 0, not 1. That will be the second index. So this scanner, I'm actually not using it. So let me comment this out because I'm actually not using the scanner here. My goal was to use the scanner. My goal is still to use the scanner, but I already answered the question 17, which is designing a program to add two binary codes. So that's done, right? And using the scanner is just a way to get fancy so that you can input the binary number, whichever one you want, manually versus just programming it here, right? Assigning the the value of the binary number during the declaration of binary one array or binary two arrays. So as you can, let's look at the code through the HTML file that I put up. Okay, we're gonna look at the code like that. Okay, let's go back to here. Let's go back to Safari, and let's look at the binary code. I think this is before I do some adjustments here. Let me take a look. Some cycle. Yeah, this is the outdated one. Let me just clear this one out. That one is outdated. Okay, this is the updated. This is the latest one. Let me increase the size too, so it's easier for everybody to read. Okay, that's much better. And these are the initial results when I put the test statements right here. Condition 6 evaluated on line 27, 923. Condition 6 evaluated. And let me show you what that is. Well, let's go. Let's first go step by step. Let me delete this one too because I already have the same here, except after the successful execution of the code. I am so excited. So, okay. So throughout the first cycle of the loop, of the while loop, some cycle is printed and cycle is printed to show us the original length of cycle, which is binary one length minus one, which is 1, 2, 3, 4, 5, 6, 7. It has to be minus one because even though that's the length of the array, the index of the array is minus one, meaning 1, 2, 3, 4, 5, 6, 7 is the length of the array, but the index starts at 0. So it's 0, 1, 2, 3, 4, 5, and 6. That's 7 minus 1. Okay, it's the same thing with some cycle, except that I gave the length the size of the array sum. I gave it more space because the sum of the binaries is always going to be larger in length than the size of the binary themselves, so larger than 7. Okay, so I always give it some extra spaces to account for the extra spaces. Okay, so during the first cycle of the while loop, which starts here on line 20, as you can see, some cycle will print the original length and cycle will print the original length. That's what we see here on lines 2 and 3. Now, on the original, as you can see on line 4, on the original cycle, that is the very first run through the loop, condition 5 was evaluated. Let's see why is that. Okay. First of all, what happens in the first cycle? 0 plus 1. Okay. The first if statement says if binary 1 and binary 2 index of cycle, which is 6, right? Which is 0, 1, 2, 3, 4, 5, and 6. So index 6 is the very last number. And that's how you add binary numbers. You start from the right to the left. Okay. So if index binary 1, 6, and in binary 2, index 6 is not equal to zeros, meaning 1 and 1, then you follow these if statements, right? But they're not. They're 0 and 1. So it jumps back to the second else if statement down here on line 39. Okay, that's on line 39. And it says else is if binary cycle 6 and binary 2 cycle 6 is equal to 0. Now they're not both. See, it says and. Right in the middle it says and. They're not both 0. They are 0 and 1. So that is also skipped. All these nested if statements are skipped. So we go back to the third else if statement on line 52. On line 52, it says if binary 1 index 6 is not equal to 0, meaning it's equal to 1, or binary 2 cycle 6 is equal to 1 or the other, which is the case here, 0 and 1. Only one is 1, right? Only one of the two is 1. So this condition is met. So it evaluates the if statements that are nested within the third if within the if else if statement of line 52, and it says is carryover equals to 0. Now carryover is only increased to 1 if the sum of binary 1 and binary 2 is 1 and 1. Then the sum is equal to 0 and you carry over 1 until the next line. Okay, so the answer to this condition here is carryover is equal to 0. Okay, so evaluates condition 5 and not condition 6, which is else if carryover is equal to 1. Carryover is not equal to 1. So evaluated condition 5. So carryover is equal to 0, then carryover will remain at 0, and sum cycle will become 1. Okay, sum will become 1. All right, so over here, that's what happened during the first cycle through the code. Okay, now on the second cycle through the code, which remember is counting down 6, 5, 4, 3, 2, 1. So 5 is the second cycle. Okay. In the second cycle, as you can see, it printed the sum is equal to 0 and carryover is equal to 0. Let's go back to condition 5. Okay. Sum cycle is equal to 1. Let's see. Where are we here? Sum is equal to 1. There is a problem there. Condition 5 is, oh wait, no, let me go back. Condition 5, here we go. Okay. Sum is equal to sum cycle minus 1. Oh, of course, I need to fix this. Okay, the reason why this says sum is equal to 0 here is because when I'm printing it down here, as you can see on line 68, down on the bottom, outside of the if of the while loop, well, the else if statement down on line 68 on the bottom, right? You see that. So here it says, let me do something here. Let me show the cursor so it's better. Okay. So it should be able to see the cursor. Okay. Give me a brief moment. I'm gonna fix that right now. Okay, so almost done. Let's fix showing the cursor. Let's show it. Okay. This way it's easier to follow. Okay, so now you can see the cursor. Okay, so over here, it says sum cycle 1. This actually should say sum cycle, period. It's what it should say. Because by the time that it reaches this statement right here, sum cycle has already been reduced to a number that is not out of bounds. So let's fix that. Let's go to the code and let's change that. Yeah. All right. So now back in the code, sum cycle should just be sum cycle. And let's run that code again and let's see the difference, right? We're going to run this code again. It's my little pony right here. Okay. All right. So As you can see now, some cycle is printing the correct number, which is equal to 1. That's what it was. And to make this a little easier to read, let me go and you lines. Okay, so here, line 5, some cycle is equal to 1. That's correct, because some cycle was 1. So I made a little mistake there, but I fixed it. Okay, so let's go back. Let's go back to the code we were reading. Let's check it out. And now, let's go check the next cycle. Now, we cannot trust line 10 because line 10 is printing a number ahead of what is actually going on because of the mistake that I made here. We just fixed that, right? We just fixed that, but we're still looking at the old printing. Okay. Now, the condition that is being evaluated is accurate, so we can continue to that, to look at that. Okay, then condition 5 is evaluated. Then on cycle number 5, which is the next cycle, the same thing happened. Condition 5 is going to be evaluated until cycle number 2, which is actually cycle number 5. So 1, 2, 3, 4, 5. So this is cycle number 2, is giving you the actual number of the index, but that is the 5th time that it goes through. So on the 5th time that it goes through, condition number 2 is evaluated. So let's find out where is condition number 2. Okay, what this means, condition 5 is evaluated, is that over here where condition 5 is, these conditions have been met from the beginning. Okay, carryover has always been 0, and one or the other is 1. One is 1, one of the binary numbers is 1, and one of the binary numbers is 0. Because the other two conditions is that both binary numbers are 0, right? 0 and 0 here on line 39 here. And the first condition is that they both be 1s. So on line 24 says binary cycle 1 with binary 2 cycle is equals 1. So let's see. As we can see up here, first binary number 2, 0 or 1, 1, 0, 1, 0, 0, 1. So the same condition has been met 4 times. That's what it shows here. So that's why condition 5, and condition 5 is evaluated 4 times. Now, on the 5th turn through, condition 2 is evaluated. Where is condition number 2? Okay, so condition number 2 is within the first if statement. It is on line 37. And that is because 1, 2, 3, and 4 cycles through, we're meeting condition 5, which is one or the other is not 0. Binary 1 and binary 2. But now here, binary 1 and binary 2 are both 1s. We're adding 1s. So condition, the first if statement condition is satisfied if binary cycle 1 and binary cycle 2 are both 1s or they're not 0. Then if carryover is equal to 1, which at this point it was not equal to 1 because it was not carrying over anything from the previous cycle. Okay, else if carryover is equal to 0, which it was in line 32, then some cycle is equal to 0 because now we're going to create one carryover. And as you can see, carryover will now be equal to 1. So condition 2 was evaluated. And here it is, condition 2. Okay, on the next 2 cycles, in the last 2 cycles, condition 6 is evaluated. So what is happening here in condition 6? Let's go back to the code. Okay, condition 5 and condition 6 are on the last else if statement that start on line 52. Okay, the last else if statements. Okay, so but this time condition 5 is being skipped. Why? Because on our previous cycle where condition 2 was met, carryover became 1. You can see right here, carryover became 1. So now in condition 6, okay, we're back to asking whether one or the other number is equal to one, which is true. This is condition 6 right here. Both of them meet the initial request, right? The initial requirement of the else if statement. So we'll see it happen twice, one or, right? We should see here that it happens twice. Condition 6 is evaluated and condition 6 is evaluated on the last two cycles. So it happens twice. Now, on both of the last two times that this else if statement is satisfied, carryover is no longer equal to 0 as on line 53. Okay, it's no longer equal to 0. Now carryover is equal to 1. So because carryover is equal to 1, this else if statement is satisfied, and then sum cycle is equal to 0 because only one of the two was equal to 0. So sum cycle is equal to 0 because now we have one of the two numbers equal to 1, but carryover is also equal to 1. So now we're adding 1 plus 1 again. Okay, and to explain it better, here we have 0 plus 1, and then on top there is a carryover. You have to imagine the carryover being on top. So 0 plus 1 is 0, or excuse me, 0 plus 1 is 1. But if you have another carryover, it's like you're adding 1 plus 1 again. So 1 plus 1 is 0 on the bottom and carry over another 1 over here, which is why this operation repeats, this condition, condition 6 over here. So here we go, 6 times through, carryover is equal to 1, sum is equal to 0, carryover remains 1. Then the whole expression is evaluated. We get to the last index 0 of binary 1 and binary 2, and the same situation repeats. Carryover is still equal to 1 from the previous cycle, and condition 6 is evaluated. Now, this right here, I'm very proud of. The last loop, which is the for loop that start here on 77. This for loop right here. This is gorgeous. Because I had to figure out how to start printing from the last index where the sum cycle or cycle carried it over a number, right? A sum. So I had to figure out a way because some array, the array sum is much larger, right? It's about 5 numbers larger than, or 5 numbers in length larger, 5 indexes larger than the binary 2 or binary 1 arrays. So I cannot start at index 0 for the array sum because that will be beyond the numbers that have been deposited into it, right? From the addition of binary 1 and binary 2. So the way I figured to do that, to start at the very last number that was deposited on sum 2 array, was to track the cycle. Some cycles started at 12 and ended at 5. Now, this is giving you the literal number of the cycle, right? But remember that the arrays start at 0, so 5 is actually 6 on an array. So we have to reduce it by 1 for the number 5 to be equivalent to the correct index in the array. So 5, the position number 5 in an array is 0, 1, 2, 3, and 4. So it's actually 4. 5, position 5 is 0, 1, 2, 3, and 4. Okay, so we have to say 5 minus 1 to reflect the index number, the correct index number. So I went back to the code and I said, okay, well, then in int a, or I could have used I, but int a, since I was already being used for the carryover index, int a is equal to the sum cycle minus 1. Now, sum cycle is no longer the sum that length, which is 12, because through the while loop, it has been reduced. As you can see here, it says some cycle minus 1. Every time a condition is met, some cycle minus 1. Every time a condition is checked, some cycle minus 1. The number has been reduced. So it is no longer 12, but instead it is 5. So 5 minus 1 is equal to 4, which is the last number, or the index where the last number was deposited in the sum array. So A is equal to some cycle minus 1, while A, which is 4, while A is less than or equal to the length of some length minus 1. And again, some length minus 1 for the same reason that some cycle has to be minus 1, because the length of the sum array is 12, but 12 in the matter of index is 12 minus 1 because it's 11. So it starts at 0. If we count from 1, then it will be 12. But because it starts at 0, 0 is a number. When it comes to array length, we have to start at, we have to say that it's 12 minus 1. So that is equal 11 in terms of array index. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 12 numbers. Okay, so as long as A is less than or equal to the sum that length, print sum A. Sum A, which is equal to the cycle 5 minus 1, which is the last index, meaning it means that we start exactly at where the last sum cycle deposited the last index, and therefore we're going to be printing just the numbers that were deposited into the array. Now, generally, when you put in an array, you have to print it backwards, okay? And for that, to show you what that means, I will need to go back to the, let's go back to my program, okay, to my code. I want to show you, I need to show you this. I'll review this during my other videos, but I'll review it one more time. Okay, so print binary value. Okay, in this class, I print a binary number. I put in a decimal and I print whatever number you want in binary. However, when you're making the calculations, which are shown here from line 27 to line 31, okay, the binary number that is being processed there is being accumulated backwards. So in the array that they're being deposited into, they are backwards. So when I print the array, I have to print the array in reverse so that the numbers come out in the right order. That may be a little confusing, but if you think about it, it will make sense. Basically, the numbers are deposited in the reverse order. So when I print the array, it has to be printed in reverse so the numbers are in the correct order. So if I run this code right here, okay, if this one will ask me, I use the input class, the scanner class. So I'm going to put yes, I like to use odd numbers, 9795. Okay, and it's going to print the binary per my code, which is 795 in binary code is this. Okay, that's my code. Now, I'm going to copy this one. Integer that binary to string is a method that Java has, or a function that can tell you the binary equivalent of any number, but I'm not going to use that. I'm going to use my own coding to show you what this does. Okay, so let's go back to Safari. I copied the code. So what? Let's go and ask Google, what is binary code? And this is what I just copied from my results, right? 795 according to Google. Okay, which is the same. Okay, it's the same as my code. Let's go back to my code. Right here, 795. There we go. So printing it backwards. Now, going back to my other code. Come on now. Okay. to my binary tree program, here I don't have to print it backwards in reverse. Now, why is that? It's because since I started depositing the numbers from the end of the array as opposed to from the beginning, the numbers are already deposited in the correct order because I started processing the arrays, binary 1 and binary 2, from the last index to the first index. I didn't start from the left to the right. I went from the right to the left, not from the beginning to the end, but from the end to the beginning. So the sums were being deposited in the correct order. Okay, in the correct order. So now I just have to print the array in the standard order, which is from left to right or from 0 to the last index. Okay, from the beginning index, I should say, to the last index. So this prints the right number. And again, let's run it one last time. And we'll see that my number is correct. Now, what is this number? Okay, actually, I did the addition already on a program, and here is the answer. Okay, here is the answer. I'll show you. Here it is. Okay, I already looked at the answer in the program, and there it is. So if you look at my number down there, okay, down here, that is, let me bring it up. Let's put some lines in here to make it easier to read. Let's show some lines here. There we go. Now, where is, here we go. And if you see on line 30 down there, okay, you see line 30 down there, you'll notice that numbers is 1000111. Now here on the picture, you see that the result in green is 01000111. The initial 0 that you see there has no value. In fact, if you go, let's check, let's go back to Safari. Let's go back to it. Okay, going back to Safari, and now I want to show you what this means. Okay, let's go back to Safari. Okay, so here we have the numbers, and let's go to what is the binary code to make sure that this is correct, right? Because over here in the picture it says, that the first number is 86 and the second number is 87. Okay, let's look at that. Right, let's go back and look at it. First number is 86. Let me bring it forward. Oh, come on. Okay, so it says here that first number is 86 and the second number is 57. Now, if you pause the video, you look at this code, okay, because I'm going to copy this code right here to Safari, so it tells us that it's true. Okay, we're going to see, and we're going to remove from the answer, the 0 that you see there, so that you see that it's the same thing. It is still 143, so that number has no value. Okay, we're going to see that now and realize that. So let's check the first number, 1010110. That number is 86. Now let's check the second number. Remember that it was 86 plus 56, right? Let's check this. Oh, come on. Let's check the second number. It was, what is going on here? Okay. It was 0111001. What is that number? Okay. No, wait. 1111001. Okay. 57 right here. Decimal 57. There it is. Okay. That is 57. Now let's look at the other number. Let's first do it like this. 0100011111. Okay, let's first do it like this. Because this is in the picture. Okay, that's 143. You see that? That's 143. Now let's do it without the 0 on front. And as you can see, that's still 143. That 0 in the front has no value. So my code successful and answer to question 17, write a Java program to add two binary numbers, has been completed. So thank you, and let's get good.